All right, so what I always do is have everyone highlight the conditions. The conditions have to be met in order to use any of the theorems. If the conditions aren't met, the theorem goes out the window. Like the whole party ends. You can't use it at all unless if the conditions have been met. And on the AP exam, they will make you mention the conditions. They won't give you the points unless you've mentioned that. I don't mind these theorems. I actually like them as a topic, but it frustrates me because then like when it translates to AP problems, if you leave out like one little thing, like on this interval or whatever, like some of the vocabulary, they like won't give it to you. So you just got to be extra vigilant. All right, intermediate value theorem. If a function is continuous, the function has to be continuous to use the theorem. If it's not, you can't use the theorem. So continuous on a closed interval, and notice like brackets, we're including that. C is any number in between these outputs, inclusive, so you can include them. Then there has to be at least one x value in the interval. And notice it could be one of the endpoints as well. Do you see those brackets there? Because some of them are different. So I'm just kind of bringing that up. Such that f of x equals c. Okay, I realize that that's like a whole lot of words. I think a picture is better. Let's draw a picture and I'll show you what it's actually saying. So just draw something. It doesn't matter as long as it's continuous. I always go with a swoop. I just like the exponential graph, so I just always draw that. So if you have this interval a to b, what we're going to do is look at the output values. So where this touches the graph, the output would be f of a, and where this touches the graph, the output would be f of b. We drew this exact same picture when we did the definition of the derivative. Do you remember this? Limit as h goes to 0. I guess instead of a and b, I called it x and then x plus h. Do you remember that? And we connected it. It's like the exact. If c is some number that's in between those, and the way you can remember that is, what does the word intermediate mean? Like if you have beginner, intermediate, advanced, intermediate means in the middle, in between. So if you have this value in between, what the theorem is saying is, since the function's continuous, this x value has to exist. This value must exist. That's what it's saying. That has to be on there somewhere. Basically, if there's an output, there was an input that gave it to you. This theorem is used a lot to prove that there's a 0 somewhere. Like if you have a positive value and a negative value and the function's continuous, 0 would have to be in between. Does that make sense? Like that's how it gets used most often, but it could be used for any number. That's intermediate value theorem. Extreme value theorem. Extreme means extremes, maximums and minimums. If a function is, all right, let's highlight the condition, because if the condition's not met, you can't use the theorem at all. So if a function is continuous on the closed interval a to b, then the function has a maximum value and a minimum value on a to b. And again, notice that there's those brackets there. So what this is saying is there must be an absolute maximum and minimum in the interval or on the endpoints. And again, we won't do a whole lot with this one today, but this is huge with what we're going to do next class. Do you remember the candidates test? Actually, that's so important. Let's just go ahead and put this here. The extreme value theorem is used with the candidates test. Does that ring any bells, candidates? Because candidates test is huge and it shows up on the AP exam every single time. That's find the absolute maximum and minimum on an interval and you test your endpoints and your critical points. Remember, you make a table, plug them all in. No, that's okay. We'll go over it next time. But anyway, that theorem that's being used is extreme value theorem. You test your candidates, which would be the critical points inside the interval and then also your endpoints. All right, mean value theorem. Go ahead and highlight. We're going to highlight the conditions. There's 2 of them this time, so look through. Your function has to be continuous on the closed interval and differentiable. Now, it's differentiable on the open interval. You can't be differentiable like at a one-sided point. That doesn't work. But continuous on the closed interval, differentiable on the open interval. Then there must be at least one value x somewhere in the, oh, and look, this one cannot be an endpoint. That's huge. That comes up sometimes because sometimes you'll work out one of these problems and you'll get x equals 2, but 2 is one of the endpoints of the interval. You have to toss it out. And you better believe that one of the other multiple choice questions will have that as an answer. So you got to be really careful. Such that, all right, what does this mean? F prime of x. That's a derivative, right? And then what is this? Slope. Derivative equals slope. It's where your instantaneous rate of change equals your average rate of change. And I will draw a picture for this one as well so you can see it. Derivative equals slope. Instantaneous rate of change equals average rate of change. So put this into perspective, like say you go on a road trip. Say you average 60 miles per hour. Now, does that mean you went 60 miles per hour the whole time? No, you averaged 60 miles per hour. Sometimes you went faster and sometimes you went slower. But what this theorem says is if you averaged 60, you went 60 at some point. Does that make sense? You can't average that without having gone 60 at some point. So let me draw a picture for this one as well, just to show you a visual of what it looks like. Because sometimes they also do this, like they'll give you a graph to look at. And let me be a little bit more careful with how I draw this. You want to have there be like a sort of like a bump in this one. Maybe you want to wait till I draw the whole thing. But here's our interval A to B. And what it's saying is if we connect those, that's our average rate of change. Do you remember Alice went for a walk? I bring that up all the time because that just rings the bells in everybody's head. Like, oh yeah, I remember that we were connecting those. That's your average rate of change, slope of a secant line. Somewhere in this interval, and I guess mine would be like kind of right about there, you can draw in a tangent line that has the same slope. So your average rate of change, I'm not an awesome artist, but do you see how those are parallel? I'm getting at there. So average rate of change equals instantaneous rate of change. That theorem is huge, and that's pretty applicable too. So Rolle's theorem is mean value theorem. There's debate even bringing it up. It's just like a special case of it. So it's if your function is continuous on the closed interval, differentiable on the open interval, and they throw in this third thing, f of a equals f of b. Basically what it's saying, it starts and ends at the same place. So if you start and end at the same place, then there has to be one value, and look, it can't be an endpoint because it's really the same theorem, where you get a horizontal tangent line. So it's the special case of mean value theorem where your derivative equals 0. Those are critical points. Following me there? Those are like, maybe write it down, critical points. Maybe that's why they like made it as a separate theorem, but it really is mean value theorem. It's just like a special case where instead of any old slope, it's specifically 0. So here, I'll draw you a picture for that too. Here's an interval A to B. You kind of need to be really picky about how you draw this one. You need it to start and end at the same place. So I did not do a real great job of that, but if you make it start and end at the same place, do you see how it's a horizontal line? Like the idea is that then there will be a place on that interval where you get a horizontal tangent line as well. So it is mean value theorem, just a special case where it's specifically 0. These theorems aren't necessarily hard. Again, on the AP exam, they're just really picky with everything you write. There's a lot of vocabulary. So we're just going to be really careful with how we write everything. So let's try a few of these, and then I will give you some to try. So number 1, find the value of x guaranteed by Rolle's theorem for this function on this interval. You have to make sure the conditions have been met. So look back. What were the conditions for Rolle's theorem? Because you have to check that first. If they aren't met, then you can't even do the problem. So that's why we highlighted them. So what has to be true for Rolle's theorem? Continuous. All right, what does this graph look like since it's a squared? Yeah, it's a parabola, it's a quadratic. Could we got both vocabulary words in there? So is a quadratic continuous? Yes. And so like on the AP exam, you would write, like I just put continuous and put a check mark there. We're gonna write a statement here, or actually we won't have to write a statement. It just says find the value. But on the AP exam, you would write the function is continuous. Like they want to see you say that. Okay. What else? What was another condition that had to be met? Differentiable. So is a parabola also differentiable? Yes. So we're good. And then the last thing was f of b or f of a equals f of b. It has to start and end at the same place. So what we're going to do is plug, this is our a and our b, if you want to like label that. So we're going to plug in each of those and see if we get the same value. It doesn't matter what they come out to. It just has to be the same thing. So what do you get if you plug in -1? 0, good. And +1? 0, good. So it doesn't matter what they come out to, as long as they come out to the same thing, then you can do the theorem. Okay, so we figured out that we can actually do the problem. That's good. So what does that mean that we do? Like, what does Rolle's theorem say? Well, it says that there's going to be a horizontal tangent somewhere, so you would do derivative equals 0. It's basically just finding your critical point, okay? So what is the derivative of that function? Yeah, that would be -2x. And we're just going to set that equal to 0. So this is a really simple derivative. They usually don't give very tricky functions for these, or else you would get a calculator. But then divide by -2 and you would just get 0. Now you need to hold on and see if that actually is an answer, because sometimes you get an answer that's not on your interval. So what was our interval? -1 to 1. So is that within that? Yes. So we get to keep that as an answer. Say we had gotten 1, would we be able to keep that though? I know some of the theorems you got to keep them and some of them you didn't. For this one, we only have the parentheses there, so you'd have to throw it out. The one you do get to keep it for, well, actually both of these. For extreme value theorem, you always test your endpoints, and intermediate value theorem, if you get an endpoint, you can keep it. But for mean value theorem and Rolle's theorem, you have to toss it out. I think I might have put one on here like that, I can't remember. All right, find the value of x guaranteed by mean value theorem. All right, is the function continuous? We have to check that first. All right, it is ln of x. I usually just like graph it off to the side. Do you remember what that one looks like just vaguely, or if you even like motion it with your hand? Yeah, it really, like usually just kind of goes like that. Now, it's not continuous everywhere. It only needs to be continuous on the interval that we are talking about. Okay, because obviously there's an asymptote and there's not even any graph over here. It only needs to be continuous from 1 to e squared. Well, here's 1. That's where the x-intercept is. What abouts is e? Like, how much is that? Like, yeah, if you know it's 2.7, good, that's perfect. 2.718. If you know it's like between 2 and 3, I'm happy. If you square that, it's going to be over here somewhere. Like, I don't know exactly what it is, but here's 1 and here's e squared. So would the graph be continuous for just like that portion, like just this piece of it? Yes, so it is on the interval we were given. Again, I realize there's an asymptote there, but on the interval we have, we're good. And is it also differentiable on that interval? Yes, okay, good. Yay, we get to do the problem. All right, so what does mean value theorem say? What are we gonna do? Derivative equals, so here's how I usually remember that. Like, do you remember when you did mean, median, mode in like math 7 or whatever that was? What did mean mean? Average. So in my head, I'm like, okay, mean means average. That reminds me of average rate of change. I'm like, okay, that's slope. Slope equals derivative. If that helps at all, that's usually how I remember that. So we're going to do slope equals derivative. So that's average rate of change. That's instantaneous rate of change. And to get a slope, you need 2 points. So how can we get our 2 points? Yeah, plug those in. So if you plug in 1, ln of 1 is 0. And if you plug in e squared, ln e squared. Well, ln and e cancel, right? So that would just be 2. So the slope is going to look kind of messy, just as a heads up. You'll be okay. What will it look like when we slope these 2 points? Right, 0 minus 2, or you could do 2 minus 0. You just have to be consistent with how you do it. 0 minus 2 over 1 minus e squared. And if you did it the other way, that's fine too. It means the exact same thing. All right, and then derivative. What's your derivative of ln? 1 over x. And then we're going to have to solve that for x. Now, when you have a fraction equals a fraction, do you remember how this is like back from algebra class? Yeah. Cross multiply. So if you cross this way, that'll be negative 2x. And if you cross this way, it'll just be 1 minus e squared. And then divide by negative 2. So 1 minus e squared over negative 2, whatever that is. But you know that that's a number, right? Like it'll be a value. Okay, let me type it in and see what it is. I guess we would want to make sure it's on the interval anyway. Any guesses? It's going to be somewhere in here. Well, it's got, well, this one won't be up to 4. That was actually kind of close there. It's 3.194528, blah, blah, blah. All right, number 3. Here's our function. Show that there is a value c on this interval 0 to 3 such that f of c equals 10. What's really tricky about these ones is they don't tell you which theorem you're going to use. But if we're trying to prove that there's some kind of output, which one of these do you think it is? Good. Perfect. Okay, you guys got that. I was worried that was going to be a struggle, but you guys got that. All right, so first thing, is this function continuous? Because we have to make sure the conditions are met. It doesn't say it's continuous, but it's a polynomial, so yeah, like polynomials do stuff like that. All right, so we need to show that 10 is between the other two outputs. So we're going to need to plug in 0 and plug in 3 and show that 10 is in between them. So intermediate means in between. Show that it's in between. So if you plug in 0 to that function, what are you going to get? 0, that's always nice. All right, 3, that would be 3 cubed. 27 minus 3 squared is 9. Plus 3, so what, 18, 21? So here's the $1 million question. Is 10 in between those? Yes, okay. Here's what's hard. You have to write a sentence and you have to include all of the things that they want to hear. And if you leave out even one tiny little thing, like it's always worth a point, you just will fail to earn the points. You got to be really careful. You have to mention the function's continuous. And it is. So we're going to say since f of x is continuous, and you can abbreviate for me, on the interval 0 to 3. And it's important you mention that interval because, like, for example, in number 2, this function is not continuous everywhere, but it is for the interval we want. So it's important to mention the interval. So since the function is continuous on the interval 0 to 3, and now this is kind of up to you how you want to write this. You can put this in your own words however you like, but in some capacity, you need to mention that 10 is between f of 0 and f of 3. Some people like to write it out in words. They'll say 10 is between f of 0 and f of 3. That's fine. The shortest way to put it would be like this with symbols. But I do get that a lot of people don't like the symbols. If you want to write it out in words, it means the exact same thing. But in some way, shape, or form, you have to say 10 is between f of 0 and f of 3. And then here's your big conclusion. You mentioned continuity. That's good. You mentioned 10 is in between. That's good. Then you get to conclude there is a value c on 0 to 3 such that f of c equals 10. You're going to just recopy the problem. Does that make sense? It's like in English class when you have to write your conclusion to your paper and you pretty much paraphrase the prompt. Do you know what I'm saying? It's that, except you don't even have to paraphrase. I want you to write it exactly. So you only have to mention 2 things. That's the good news. Continuity and that 10 is in between the other 2 numbers. Here's the bad news. If you left out this whole first line, they would not give you the point. If you left out this interval, they would not give you the point. Like you have to mention every single one of those things. Okay. We'll practice more writing justifications when I get closer to May. All right, last one. Find the value of x guaranteed by Rolle's theorem. All right, there's 3 things. The function has to be what? All right, is this continuous? Yes, good. It also has to be differentiable. Is it differentiable as well? Yes, polynomials just do this. They're continuous and differentiable. And then the last thing for Rolle's theorem, because that was, where we have a 0 tangent line, it has to start and end at the same place. So we're going to plug in 0, plug in 3. It does not matter what they equal, but they have to equal the same thing. So if you plug in 0, what are you going to get? 2. And let's see, 3, that would be 27 minus 27, which is nice. Plus, oh my gosh, they came out to the same thing. So yay, we get to do the problem, but that means what do? Sometimes it's like, oh, we get to do the problem. Wait, how do I do the problem? Good, derivative equals 0. So what is this derivative? Okay, that'll be 3x squared minus 6x, and actually that's it. Set it equal to 0. And then I have to get through the algebra, so what next? Yeah, we can take out 3x. That'll leave us with x minus 2. And so we get 0 and we get 2. Now you have to check them. For intermediate value theorem and extreme value theorem, you're allowed to keep those endpoints. See these brackets here? You can keep them. For mean value theorem, and Rolle's theorem is just a version of mean value theorem, you can't keep the endpoints. Okay, so do we get to keep both of these, get rid of both of these, keep one or the other? What do you think? Keep 2, not 0, because that is an endpoint. On the AP exam, they would make choices like A, 0, B, 2, C, 0, and 2. Do you get what I'm saying? Like they'll throw the other one in there. I'm going to erase that because I don't want that to confuse you when I post these notes up there, but you just have to be really, really careful.